Assalamu alaikum. In this lecture, we are going to study the effect of snow and wind over the sag calculations of the transmission line conductors. Till this point in all the sag calculations, we were only considering the normal temperature, and for the weight, we were taking the conductor weight as the only force that is acting downward. But now if we will consider the atmospheric condition, we have ice as well as wind that will have an impact on the weight of the conductor, right? So ice will form a coating over the conductor and it will be an extra weight that is added to the conductor, and we also have the wind pressure that is acting on the conductor. And whenever we are assuming the wind pressure, it is actually considered to be acting horizontally over the conductor. So now what we have, the actual weight of the conductor is W, and if we add the ice weight, then the total weight that is acting downward is Wi plus smaller w, and then we have a horizontally acting wind. So this is the pressure that is induced over the conductor by the wind. So the actual weight of the conductor, which is loaded with ice as well, is at an angle theta with respect to the vertical weight that is acting downward. So this is your total weight when we are considering the wind as well as ice. So now if I have to calculate the total weight per unit length of the conductor, total weight per unit length, and from the figure we have a right triangle. So we know the formula that hypotenuse is actually equal to under root perpendicular square plus base square, and at the hypotenuse we have the total weight, at base and perpendicular we have the wind pressure and the weight of conductor plus ice loading. So we have W plus Wi square plus wind pressure square under root. So this is the total weight that we have to calculate, and in this formula we only know the weight of the conductor. So now we have to calculate the weight of the ice loading as well as the wind pressure. So we will be starting from the Wi, which is the weight of the ice. So now if I have to calculate Wi, it is actually multiplication of density of ice and volume per unit length. So this is the formula for the calculation of weight of ice. So first we have to calculate the volume of ice, and we will know the density of ice, and we will just multiply that and we will get the weight of ice. So for the volume, this particular conductor, it is actually a cylinder, right? So the volume of cylinder is pi r square h, right? And in this case we are considering per unit length, so we will consider h is equal to 1 meter. So because per unit length, so volume of cylinder is actually equal to pi r square. So this is the volume of conductor in this case, and replacing radius with the diameter, so it will become pi d square over 4. So this is the volume of conductor. So now if I have to find the volume of ice, because in the formula we have to calculate the volume of ice. So for volume of ice, we have to calculate first the total volume, and then subtract the volume of conductor from it, right? So we have calculated the volume of conductor, which is pi d square over 4, and the diameter is actually this one, right? And now we have to calculate the total volume, and for the total volume it is again a cylinder, but now the diameter is changed, right? In this case it is d plus 2t, so one t is in this portion and the other t is this one. So now the total volume formula will be pi by 4 into d plus 2t square minus, what is the volume of conductor that we have calculated? It is pi d square over 4, and after solving it will become pi by 4 into d square plus 4t square plus 4 dt minus d square, and it is pi by 4 into 4 t square plus dt, and the final formula will be pi t d plus t. So this is the volume of ice per unit length. Okay, so what we wanted to calculate, it was the weight of ice, right? So density of ice, that will be given to us, and the volume of ice per unit length, we have calculated that, and if I have to calculate the weight, we just have to multiply these two quantities. So now the second part is the wind pressure. Now we know the weight of the conductor and we also know the weight of the ice. Now we have to calculate the wind pressure, right? For wind pressure, wind force per unit length. So now we have to calculate the wind pressure, and it is denoted by WW. It is equal to wind pressure per unit area into the projected area of the conductor per unit length, right? We know that the formula for the pressure, it is actually equal to F over A, force per unit area divided by the area. Now if I have to calculate the force, wind force per unit length, F, it is actually equal to pressure per unit area into projected area. So that is the same formula that we know, right? So we know the pressure value. Now we have to calculate the projected area, right? For the projected area, we are given with a conductor. So for example, we have a conductor. So this is a cylinder, right? But when a wind is being applied from this direction, the projected area of this particular conductor will be this rectangle, right? So when the wind is acting on the conductor, it is just like it is acting on the rectangle. So the projected area of the conductor is rectangle. So now if I have to calculate the area of rectangle, so area of rectangle is length into width, right? So the width is actually d plus 2t, and the length is per unit length, so I will take 1 meter, and now this is the diameter of the conductor, and this t is the factor that is introduced by the ice loading. So we have 2 t's on either side of the conductor, so that's why I have taken width equal to d, diameter of conductor, and 2t, that is introduced by the ice loading. So the projected area, which is equal to d plus 2t. and from the formula for the wind force, it was wind pressure per unit area into the projected area. So now we have calculated all the values that are needed for the calculation of the total weight. So we already know the weight of the conductor. Then we calculated the formula for the ice loading, which is density of ice into volume of ice. So we calculated the formula for volume of ice and multiplied it with density of ice. We got Wi. And for the wind force, we calculated it by using the formula wind pressure per unit area into projected area. So whenever the wind is acting on the conductor, the projected area of the conductor is a rectangle. So we calculated the area of rectangle and multiplied it with the wind pressure per unit area. So we got the value W by W, which is the weight quantity that is introduced by the wind. So in this way we can calculate the total weight of the conductor whenever we have ice loading and the wind is blowing as well. So this was today's lecture. In the next lecture we are going to solve some examples related to the sag of the conductor. That's all for today. Thank you.